Hello and welcome to Containers 211. My name is Ike Arias and I am with the Container Services team here at AWS. Joining me for this session is Jeremy Eder, who is a distinguished engineer at Red Hat. During this session, we will be talking about the upcoming AWS Managed OpenShift offering that we're launching soon. It's called Red Hat OpenShift Service on AWS, or ROSA. We'll start with a short overview of what OpenShift is. We'll present the two main options that our customers have today to run OpenShift on AWS. We'll then introduce ROSA as a new third option, and we'll dig a little bit deeper into how it's different and why we think customers will find it the easiest and best way to run OpenShift on AWS. Then Jeremy will show what a ROSA cluster looks like when running on AWS accounts, and he'll show a demo of deploying ROSA OpenShift clusters from scratch. Finally, we'll let you know where to go if you're interested in this new service to find out more. OpenShift is a container and application platform. Developed and supported by Red Hat, it's built on top of Red Hat Enterprise Linux and Kubernetes, two of the largest and fastest growing open source projects in the world, and adds several services to offer a well-rounded platform experience out of the box. These include cluster services such as monitoring, managing, and updating the cluster services such as built-in CI/CD pipelines and logging, application services such as databases, language runtimes, and many others through what's known in Kubernetes as operators, and developer services such as a rich console, CLI, and tools for code editors, IDEs, and more. An important point is that regardless of where customers run OpenShift, the experience remains consistent, which is a highly sought after feature. As I mentioned, there are two main ways for customers to deploy OpenShift clusters on AWS today. The first one is self-managed, meaning that the customer is responsible for the configuration of the infrastructure and the environment, the installation of the platform, and the ongoing management of the system, including monitoring the health of all components, applying software updates, adjusting for capacity changes, and more. OpenShift Container Platform, or OCP, includes an installer that facilitates this process, and Jeremy will expand a bit more on this. This is a great option for customers with a need to customize the cluster installation, integration points, and tooling, and who have the skills and ability to do so. The alternative is OpenShift Dedicated, a fully managed OpenShift experience. With this option, the customer is no longer responsible for the installation, care, and feeding of the platform, which is now managed by Red Hat's expert SRE teams. This is a great option for customers who want to avoid managing the whole environment and or prefer to focus on just building the applications. ROSA is a new option for people who want to consume OpenShift on AWS in the same way they consume other AWS services. It's similar to Dedicated in the sense that it's a fully managed offering, but it introduces some important changes driven by feedback that we've got from customers. In addition to the benefits of OpenShift Dedicated, you'll gain the ability to kick off a cluster provisioning directly anytime you need one, and you'll pay only for the usage you give it. If you no longer need a cluster, you can deprovision it, and you'll be billed only for the time that it was running. In summary, ROSA provides all the benefits of OpenShift Dedicated, but it will be available directly on AWS for customers to deploy. The billing model is consumption-based, so for use cases that call for clusters to run for a limited time and then be torn down, you'll pay only for the time you used it. And you can leverage your existing AWS commitments for infrastructure. The billing model is unified, so you'll pay for all of this at the end of the month on your AWS invoice. And for support, you can also go straight to AWS, and AWS will handle all your escalations. So it's really a one vendor option for running OpenShift. We're also working with Red Hat on expanding some of the integrations with other AWS services in the future. Now I'm going to hand it off to Jeremy to show us a little bit more about what an OpenShift cluster in ROSA looks like running in one of your accounts.
Yep. Thanks, Ike. So here's an architecture diagram of what a ROSA cluster looks like when it's deployed in your AWS account. The ROSA service leverages installer provisioned infrastructure support provided by OpenShift Container Platform. IPI leverages the AWS cloud provider in Kubernetes to ensure that all ROSA clusters are deployed according to best practices. It's also responsible for creating instances, security groups, ELBs, and so forth. The ROSA product supports both single and multi-AZ deployment options. Red Hat recommends multi-AZ deployments for production so that your cluster can survive AZ outages. Single AZ deployments are typically used when that level of availability is not required, such as for development clusters. The ROSA topology includes a 3-node control plane cluster, which runs Kubernetes services like the API server, scheduler, and etcd. If you choose multi-AZ deployment, each of those control plane nodes ends up in a different availability zone. Access to the Kubernetes APIs, like if you are running kubectl, is routed through what we call internal NLBs. This allows for transparent maintenance of control plane nodes. Access to your applications running on the cluster goes through a different set of ELBs. These sit in front of the OpenShift HA proxy-based routers and handle ingress into the cluster. Because a ROSA cluster runs within your AWS account, you can control whether this cluster can access resources elsewhere in your AWS environment. The ROSA topology also includes 2 infrastructure nodes. These nodes run cluster support services like the built-in container registry, which uses Amazon's S3 for its object storage, and Prometheus and Alert Manager, which use EBS for their persistence. The OpenShift routers handling your application traffic also run on these nodes. We separate these workloads from your deployment to assist with capacity planning and to ensure that they don't compete for resources. The third type of compute resource in an OpenShift cluster is called a worker pool. By default, this will have 3 nodes in it, each in a different AZ. This pool can be scaled up or down using the ROSA CLI utility. Separately from the default worker pool, you can create additional worker pools. These could have different instance types, but will still run in the same region as the cluster itself. Each machine pool can be scaled up or down independently. So that's a typical ROSA cluster topology. For accessing the cluster, we offer both public and private cluster scenarios. A public cluster can be accessed over the internet, for example, when you're running public-facing applications. In contrast, a private cluster is not accessible over the internet. To access it, you'd establish a peering connection from your access point into the VPC that your cluster is deployed in. The ROSA service will let you change the visibility of your cluster at any time, as well as toggling access to the API server, cluster ingress, or cluster ingress independently. So let's head into the demo now and show you how easy it is to use the ROSA CLI to provision and manage OpenShift clusters on AWS.
Let me start with the CLI, which is called ROSA, and it's written in Golang, and the code's available on GitHub. The command line is available for Windows and Mac, and it's also available for Linux, which is what I'll be using for this demo. So let's begin. Here are the options available within the ROSA CLI today. Your typical create, read, update, delete operations, as well as helper commands like whoami and init. So starting with ROSA whoami, here you can see which AWS account you're logged in with, as well as that you're also logged into OpenShift Cluster Manager, which provides a number of the backing services for this offering. The ROSA CLI uses the default configured AWS profile or you can specify a profile by passing --profile option to any of the ROSA commands. We also support passing credentials via environment variables like the AWS CLI. After making sure you've got your credentials configured, the next step is to run the init command. So ROSA init. While that's running, the init command bundles together several validation steps to make sure you can deploy a ROSA cluster into your existing AWS account. It validates credentials, checks for any SCP policies that may block deployment, checks for necessary permissions and quota. It also runs some dry runs of instance creates to make sure everything is all squared away. As you may know, quotas per region, and ROSA uses a default region if one is in your AWS config file. So in my case, it validated US East 2 because that's my default. If you plan to deploy to a different region, you can change your default, or you can pass --region to the ROSA init command. So speaking of the regions, I can list them out here. And these are the same list that's supported by the OpenShift Container Platform product. So 16 regions now. And if new regions are added to the OpenShift product, they will follow along into the ROSA service. Also, as I kind of skipped over this, but one part of the init command is verifying whether the OpenShift command line tool is available. So what is the OpenShift command line tool? That's a client similar to kubectl that helps you interact with your OpenShift cluster. I've actually already got it installed on this workstation, but we have a helper command to download the client. ROSA download OC, it pulls down the latest client for the operating system that you're running on, and yeah, you'd have to unpack it to install it. So I've got that installed already, and let's just make sure that it is, yep, and it's the latest version, which as of the time of this recording is 4.6.4. So that OC client package also includes kubectl along with some OpenShift specific add-ons. So let's actually try and create a cluster now. So ROSA create cluster, and let me run through the help options really quickly. So there's a lot here. It's quite customizable actually, but instead of creating a mile-long command line argument, we have a helper option called interactive mode. So what this will do is it'll lead me through kind of a wizard for standing up my cluster, along with offering me some inline help if I'm not sure what a particular option might mean. So my first question is the cluster name. Let's call it JEater ROSA. And next question, multiple availability zones. So what this will do is it will deploy the control plane nodes and worker pools spread across 3 availability zones. And that's our best practices for any production deployment. So I will choose yes here. If you didn't choose yes, it would deploy everything in the same AZ, which is fine from an OpenShift redundancy standpoint, but doesn't give you that multi-AZ redundancy, which are best practices. So choose yes for that. And then if you remember the list region command I ran earlier, this is the corresponding list of regions, and my default was US East 2, but I don't know, let's put it somewhere else. How about EU Central 1? And then it's asking me for what version of OpenShift I want to deploy. So let me see here. I can choose, I'll choose the latest one right now, 463. And let's see, now it's giving me a question about the instance types. So these are for the compute nodes, not for the control plane master nodes. In this case, doesn't really matter too much. I'll choose M5 2X large for those. A minimum of 3 compute nodes. It's going to put 1 in each availability zone, so I'll just leave that by default to 3. And then there's some networking questions, which come into play when you're trying to deploy, basically when you're trying to connect your network, if you wanted to peer into the VPC that this cluster is deployed into. You may have some subnetting requirements there. I'll skip those for now. And let me just zoom in for a second on this last question. So we've gotten a lot of customer demand for making clusters private, meaning they're not accessible over the internet. And that's what this option is here. So if you deployed a cluster as private, you would, it would deploy just fine, obviously, but you would not be able to access the API or the web console until you establish that VPC connection, that peering connection into the VPC. So I'll leave this one as public for now. And it's going to go off and create this cluster for me. Okay, cool. So yeah, the output here is the cluster name, an internal ID for it, tells me which AWS account it was provisioned into, the topology of the cluster, the region, and here's a field called state. So we do several pre-flight steps before actually beginning the cluster deployment. One of them is preparing the AWS account. We also allocate a Route 53 DNS zone for the cluster, and we're preparing that with all of the scaffolding. And okay, so that is the cluster that's currently being deployed. The rest of these fields will be filled in as the cluster is deployed. So what'll happen after those pre-flights is the OpenShift installer will get kicked off, and if you had a need to look at the logs of the actual installer, we plumb those through as well, and they may not be immediately available. Yeah, because our pre-flight steps are still running. Within a couple of minutes after the installation kicks off, you'll see debug level logs there if you ever needed them. So that install is going to take, it's going to churn away for a bit. I have a cluster that I've previously installed. So let me show that now. And if I do list clusters, I've got, so this JEater ROSA 1 is in a state of installing, and then I've got JEater reInvent, which is ready, and that cluster's been up for a bit now. Let me show you what that looks like if I were to describe that. Okay, so this one has all of the fields filled in, including console URL and a details page. So let's start with the console URL. And I've got that pulled up over here. Let's see. So this is the console of the cluster that I had previously installed. This is the standard OpenShift overview page. You have access to Operator Hub, and there's just dozens or even hundreds of optional pieces of software, ISV software that you could potentially install. We have also some dashboards about the cluster, this particular cluster itself. This one is about etcd. We also have cluster-wide resource utilization dashboards, which tend to come in handy. And we also have, there's plenty in here, some machine sets, and these are the workers and control plane nodes and infrastructure nodes that are part of the default installation. So that is that. What if you're trying to deploy an application that needs more resources or needs different types of nodes, for example? Let me flip back to the CLI, and let's try and add some more resources to this cluster. The way this works is on the concept of machine pools. And let me first list out what we've got. And so there's a default machine pool. That's the M5 2x large that I had chosen during the cluster provisioning. And let's try and add a new machine pool. And I'll do it in interactive mode as well. So we'll give it a name, and let me call it pool 1. Number of replicas, this is the number of nodes that are part of this machine pool. Since I've got a multi-AZ cluster, this will be, I'll need to choose 3 for 3 AZs. And then I can choose the instance type. Let me choose something else. M5X large. And what's happening in the background here is OpenShift is going out to AWS, spinning up the quantity of these instance types that we choose with a certain AMI, and it's going to join it to the cluster. If you wanted to target a workload at this machine pool, you can use a label selector for that. So I can label it, for example, test label equals true, and then every node within this machine pool will get that label. Cool. So let me list the machine pools again. And so those objects were created. You can see pool 1 with 3 replicas of the instance type, M5X large, the label, and so forth. So these were requested, but like I said, it's going off to AWS in the background, and so it's not immediately available to you, but it will in the next couple of minutes become available. So the next step I wanted to show you. So earlier in the ROSA describe output here, we also see this details page, and that is the OpenShift Cluster Manager. So we have, let me pull that up here. So this is the OpenShift console, and then if I pull up the OpenShift Cluster Manager console, you can see I've got the reInvent cluster, which is in ready, and I've got this new cluster which we created today, which is still in installing mode. If I click on the reInvent cluster, which is the one we just created machine pools on, says there's an overview page, resource utilization. You can see the type here is ROSA, provider AWS, and the billing model is through AWS. So you'll receive, your AWS invoice will include the ROSA product. If I pull up this machine pools tab here, you can see pool 1 is here, and I could also let me just add another machine pool to this, and this time maybe, I don't know, R5X large, number of workers per zone, so 1 per zone, so a total of 3, and then the machine pool name pool 2. If I click add machine pool, it's going to go ahead and do that. So yeah, same thing with the CLI or OpenShift Cluster Manager equivalent operations. If I flip back to the OpenShift console now, and let me click on machine sets, you can see here there are some of these rows have 0, 1. That's pool 1, and then you can see pool 2 here as well. And as those machines come online, they will show up. 1 of 1 will show up here.
Thank you, Jeremy, for that demo. If you are interested in learning more about ROSA, here's a link that you can follow to find out more about it. And you can sign up for a public preview starting now. We expect the service to be GA sometime in Q1 of 2021. Thank you very much for joining us today and for your attention. And please fill out the survey at the end of this.